We're looking at number 26 from 1.3, where we've been given the function f of x is x cubed minus 1 over x squared minus 1. And we're asked to give a formula for the extended function that is continuous at the indicated point. And our indicated point on 26 is x equals 1. So then our assumption is probably that this function as it stands now is discontinuous at x equals 1. And let's confirm that with our graphing calculator. So let's type in to our TI-84 or into Desmos an x cubed minus 1 over x squared minus 1. And let's hit enter and let's go zoom and for zoom decimal. So there's the graph. Okay. So we type zoom decimal, so every single pixel on the calculator is given a value of 1/10, and that way we can really find out if there are any holes at integers. And it turns out there is. We have a hole at 1 comma some y value here in the graph. So with that in mind now, we're going to go back to our whiteboard, and we're going to remember that in order for a function to be continuous at some point, in this case 1, we need to show that the limit as x goes to 1 of our function is equal to f of 1. And right now, f of 1 is not possible because when we plug in 1, it's clear to see we get 0 over 0. And you may recall from previous math studies that 0 over 0 is called the indeterminate form. And that's usually almost like a breadcrumb like clue that there's something more that can be done. So let's take a look at this function. I'm noticing that these are both factorable polynomials. So maybe the idea would be to factor and kind of see what happens from there. So x cubed minus 1 factors into x minus 1. It factors into x squared plus an x plus a 1. In the denominator, we factor that into an x minus 1, x plus 1, and then we can see that the x minus 1s cancel, and we have x squared plus x plus 1 over x plus 1. So let's head back to our graphing calculator and see if this new function truly does the trick. So I'm going to type in a new one. It's going to be x squared plus x plus 1. And that's going to be on top of x plus 1. And before we hit enter, if this truly does what we want it to do, this function y will agree at all but 1 point. And that 1 point where it will disagree will be where the hole was in f. And we should have a continuous and smooth function there. So let's take a look at the graph. Here it comes in red, right on top of the old one. And the hole got filled. So perfect. That did exactly what we want it to do. Back to the definition of continuity. Can we agree with this statement? Does the limit as x approach 1 of the function equal f of 1? And it does. And what is that value, by the way? In other words, what is y of 1? It's 1 plus 1 plus 1 over 1 plus 1. So I guess it's 3/2. That was just more for clarity's sake, and that does appear to be about 1.5, so that's right. But anyway, back to the question, what is the extended function? It's this. It's our answer of x squared plus x plus 1 over x plus 1. It is continuous at x equals 1, but everywhere else, it matches the behavior of x cubed minus 1 over x squared plus 1. Hope that helped.